On July 23, 2026, owners of the June smart oven received a message that changed what their kitchens would be able to do. Weber, which had acquired June years earlier, said the June mobile app and its cloud-connected services would end on September 22nd. Consumer rights, wiki. The heating elements would still work. The touchscreen would still work. But remote control, alerts, live video, and cloud features would disappear. Nothing inside the oven had physically worn out. No motor had seized. No heating coil had burned through. A service was simply being removed. That distinction matters because it exposes the strange new fault line running through appliances that are half machine and half internet product. For most of the 20th century, an appliance became worse when its hardware degraded. In 2026, it can become worse because a server stops answering, and that raises a more uncomfortable question than whether one's smart oven survives. What exactly do we own when useful functions depend on permission? The June shutdown is not proof that manufacturers are secretly programming every appliance to die. The evidence points to something subtler. The architecture itself gives manufacturers the technical power to add, remove, meter, or discontinue capabilities after the customer is paid. Sometimes that power produces useful updates. Sometimes it fixes security flaws. Sometimes it adds a new cooking mode years after purchase. But the same update channel can also become a one-way gate through which the manufacturer decides what the hardware is still allowed to be. That is the real 2026 story. The kill switch is often not a dramatic command that makes a refrigerator go dark. It is the gradual migration of control away from switches, dials, and local circuits, and into accounts, applications, cloud APIs, and licenses. Once that migration is complete, the appliance can be physically present in your home, while part of its functionality lives somewhere else. And somewhere else can be repriced, redesigned, acquired, abandoned, or switched off. The June oven made this visible because its intelligence was easy to see. A camera watched food. Software identified it. Programs adjusted cooking. The app let owners monitor meals remotely, view live video, receive notifications, and use connected features that help define the product. June oven. Weber says the oven will continue to cook locally after the connected platform closes, provided owners have the final software installed. Consumer rights, wiki. So the hardware is not being turned into a brick, but a portion of the purchased experience is being permanently amputated. That difference between total failure and capability loss is where smart appliance ownership becomes difficult to describe. A conventional toaster has a small universe. Current enters a heating element, a thermostat, or timer controls it. The logic lives inside the object. A connected oven has a larger universe. It may depend on an account system, authentication tokens, certificates, mobile operating systems, cloud databases, content servers, analytics, and remote APIs. The oven can be sitting 3 feet away from you, while part of the path required to use a feature crosses several networks and corporate systems. This is not automatically malicious. Cloud services cost money to operate, secure, maintain, and update. Mobile platforms change, security standards change, companies disappear. But from the owner's perspective, the cause matters less than the result. A durable physical object has inherited the mortality of short-lived software. That mismatch is now measurable. In 2026, computer scientist Eric Buchman published an analysis of long-term risks in smart refrigerators, Archivum. The work examined 3 representative connected refrigerators and mapped 8 use cases, from basic cooling to monitoring, shopping, multimedia, remote control, apps, and updates. The unsettling result was not that every smart fridge will suddenly stop cooling. It was that even basic functions can become exposed to external dependencies. Archive. If temperature configuration, alerts, or control paths rely on a phone app, a vendor account, or cloud infrastructure, the owner does not control the entire system. The refrigerator may be engineered to last for a decade or more, while the phone operating system it talks to changes every year. The cloud service may be redesigned, encryption certificates expire, old cryptographic protocols are deprecated, app stores raise minimum operating system requirements, third-party voice assistants change interfaces, Wi-Fi security standards evolve, vendor libraries stop receiving patches. Authentication systems are replaced. Each component can be perfectly rational on its own and still produce an irrational appliance lifecycle when chained together. This is software rot without rust. The compressor may still be healthy, while the digital ecosystem around it becomes incompatible. And that is why the phrase smart appliance can hide a structural reversal. Intelligence is sold as an upgrade, but dependence comes bundled with it. Consider what happens when a physical control is replaced by a software control. A knob is local. Its behavior does not require an account. A phone-based control is different. The app may need a login. The login may need a vendor server. The server may check a token. The token can expire. The account can be suspended. The API can be retired. The app can stop supporting your phone. The hardware has not failed. The chain of permission has. There is another failure mode hidden inside that chain. Certificates and protocol versions. Connected products prove their identity through digital certificates, encrypted sessions, and software libraries that must remain mutually compatible. If a root certificate expires, an old encryption library is rejected, or a server stops accepting an obsolete API, a device can lose cloud access even though its radio still works. Engineers can sometimes prevent this with an update, but that creates a circular dependency. The appliance may need the vendor's update infrastructure in order to receive the fix that keeps it compatible with the vendor's infrastructure. If support has already ended, the owner may have no authorized path to install a replacement. Mobile apps add another clock. Apple and Google retire old operating system versions. Permission models change, and developers eventually stop testing obsolete hardware. A 10-year appliance can therefore depend on a 2-year-old phone requirement that did not exist when the appliance was sold. None of this requires a sinister timer. It only requires the manufacturer to remain the sole bridge between old hardware and a changing digital environment. When that bridge is removed, obsolescence arrives from outside the machine. And because consumers cannot normally redirect the appliance to an independent replacement server, a compatibility problem that would be repairable in an open system can become final. Manufacturers often describe this architecture as a benefit because it allows products to improve after purchase. GE Appliances, for example, promotes downloadable upgrades for connected ranges, ovens, and washers. Certain cycles and features can appear through Smart HQ after the appliance is connected. That model can be genuinely useful. An oven can receive a new mode without a service visit. A washer can gain a specialized cycle after leaving the factory. GE Appliances. But it also changes what the buyer is purchasing. Some capabilities are no longer fixed. At the moment, money changes hands. They are software-defined, and software-defined features can be controlled by software-defined conditions. The condition may simply be an internet connection. It may be a registered account. It may be a compatible app. It may eventually be payment. Whirlpool's connected appliance terms make this possibility explicit. Depending on the product and market, some smart features can require connected subscription. The terms also reserve the ability to modify or discontinue subscription plans, features, and pricing. That language is important because it describes a relationship that would have sounded absurd for a washing machine a generation ago. Whirlpool.ca. You can own the steel drum, motor, pump, cabinet, control board, and radio while continuing to rent access to a software capability layered on top. Anova provides an even clearer example of how recurring payment enters the kitchen. The company introduced a subscription for new users of its connected sous vide app, explaining that every connected cook creates ongoing service costs. Anova culinary support. That argument is economically coherent. Running servers, maintaining apps, storing recipes, supporting authentication, and shipping updates are not free. But the business solution exposes the underlying design decision. A product that needs a continuing service creates a continuing financial relationship. Once a manufacturer has that relationship, the appliance is no longer merely a one-time sale. It can become a platform. Platforms want active accounts. Platforms want recurring revenue. Platforms can segment free and paid tiers. Platforms can test which features users value enough to keep paying for. That does not prove a conspiracy to destroy hardware. It creates something more ordinary and, in some ways, more powerful, an incentive structure. If a connected feature costs money forever but produces revenue only once, the manufacturer eventually has 3 basic choices. It can subsidize the service indefinitely, shut the service down, or charge someone to keep it running. That arithmetic is why cloud-dependent products repeatedly encounter the same ending even when nobody ever writes a malicious brick-the-device command. The danger is designed in at the beginning, when a feature that could have been local is made dependent on infrastructure the customer cannot operate. That architectural choice can be intentional even when the eventual shutdown is not. This is where the word bricking needs precision. In engineering, a true brick is a device rendered unusable, often because firmware corruption prevents it from booting. Smart appliances more commonly suffer partial bricking. A connected layer dies while the mechanical core survives. The user experiences a product that is still functional but no longer identical to the one purchased. A camera becomes useless. Remote control vanishes. Automation stops. A premium program disappears. A dashboard no longer loads. For the manufacturer, those may be services. For the buyer, they may have been the reason to choose the expensive model. That gap between contractual language and lived ownership is the center of the dispute. It becomes even more complicated because firmware has legitimate authority over hardware. Modern appliances need software for safety, efficiency, diagnostics, and precise control. A refrigerator controller manages compressors, fans, defrost cycles, sensors, ice makers, and alarms. A washer coordinates pumps, motors, valves, locks, and imbalance detection. Bad firmware can absolutely make a good machine unusable. So can a failed update, a corrupted flash chip, or an incompatible control module. Manufacturers, therefore, need secure update mechanisms. The problem is not that firmware updates exist. The problem is who ultimately controls them and what happens when support ends. If an update is cryptographically signed, the appliance may reject any software not approved by the manufacturer. That protects against malicious code, but it can also prevent independent developers or repairers from maintaining abandoned hardware. If diagnostic tools require authenticated access, a local repair shop may be able to replace a board, yet still lack permission to pair, calibrate, or configure it. If replacement components contain identifiers that must be accepted by vendor software, a mechanically successful repair can remain electronically incomplete. This is how ownership can be narrowed without anyone confiscating the object. The consumer possesses the appliance. The manufacturer retains authority over crucial digital states. That authority can be used responsibly. It can prevent dangerous modifications, verify authentic firmware, protect safety systems, and close security vulnerabilities. But the same control plane can also enforce product segmentation, subscription entitlements, service restrictions, and end-of-life decisions. Security and control are not opposites. Often they are implemented by the same mechanism. A signed firmware package says only approved code may run. An entitlement server says only approved features may run. An account system says only approved users may access them. The technical difference is real, but the power relationship is similar. And once the appliance is connected, software can modify the product after it enters your home. Samsung demonstrated another version of this in 2025 when it began rolling advertisements onto some Family Hub refrigerator displays through software updates. The refrigerator is still cooled. No subscription was required to open the door, yet the interface of an already purchased appliance changed because the manufacturer controlled the screen. The Verge. That episode matters less for the ads themselves than for what they reveal about post-sale authority. A refrigerator door used to be a surface the owner controlled. A connected display can become remotely programmable real estate. The same principle applies to feature promotions, service notices, recipe platforms, shopping integrations, energy programs, and paid upgrades. Once an appliance contains a general-purpose screen, network connection, account layer, and update channel, it starts behaving like a media platform. And media platforms rarely remain economically static. The usual defense is that customers can simply disconnect the appliance from the internet. Sometimes they can. Many smart appliances retain their core functions offline, and that distinction should not be ignored. GE Appliances states that already downloaded features on some products remain available if Wi-Fi is interrupted. The June oven will continue local cooking after its cloud services end. A disconnected smart appliance is therefore not automatically a dead appliance. But just disconnect it misses the larger issue, because some capabilities are sold specifically on the condition that the appliance remains connected. GE Appliances. Remote notifications cannot work without a network. Cloud video cannot work without a server path. Voice assistants need external services. Some downloadable cycles require connectivity to obtain them. Diagnostics, energy dashboards, recipe libraries, and automation can depend on remote systems. Disconnecting restores privacy and independence only by surrendering part of what the premium price purchased. That is not equivalent to owning a product designed to be fully local from the start. The local versus cloud choice is therefore the most important design decision in the entire smart home stack. A local system keeps essential logic, controls, and state inside the appliance or home network. A cloud-first system treats the appliance as an endpoint in a service operated elsewhere. Cloud-first design is attractive to manufacturers. It simplifies fleet management. It enables telemetry. It allows rapid updates and centralized security fixes. It also gives companies visibility into how products are used, which errors occur, which modes are popular, and which features attract engagement. That data can improve reliability. It can also inform monetization. If telemetry shows that owners repeatedly use a specialty cycle, a company knows that cycle has economic value. If the feature is delivered through software rather than a dedicated mechanical control, it can theoretically be packaged, promoted, bundled, or restricted. This is the same logic that transformed cars, printers, entertainment systems, and business software. The appliance industry is not inventing subscription economics. It is importing a proven digital business model into objects that historically behaved like property. The transition feels more aggressive in a kitchen because appliances occupy a different psychological category. A streaming service is expected to stop when payment stops. A refrigerator is expected to keep being a refrigerator because it is physically yours. When those models merge, expectations collide. The most revealing documents are often not advertisements, but terms of service. Marketing tells buyers that connected products get better over time. Terms usually preserve the company's ability to change smart features, suspend services, modify pricing, or discontinue connected functionality. Both statements can be true at once. The appliance can improve for several years and still depend on permission that can later be withdrawn. That is why ownership needs to be separated into layers. You may own the chassis and electronics. You may receive a license to embedded software. You may access remote services under terms that can change. You may purchase optional subscriptions whose features exist only while the subscription remains active. To the consumer, all of those layers appear as one refrigerator, oven, or washing machine. To the contract, they are different things. This fragmentation becomes critical when a company is acquired. The June oven is a near-perfect case study because the product's physical lifetime outlasted the strategic priorities of the company controlling its cloud. Weber did not need to enter customers' homes or remove components. It only needed to stop maintaining the external systems that completed the experience. That is a new form of product aging, not material exhaustion, but corporate abandonment. And corporate abandonment scales differently from mechanical failure. When one compressor fails, one refrigerator is affected. When one cloud platform closes, thousands of otherwise functional devices can lose the same capability at once. The failure becomes centralized. That centralization is efficient while everything works. One update can fix an entire fleet overnight. It is equally efficient when support ends. One decision can downgrade an entire fleet overnight. This is the paradox at the center of smart appliances. The architecture that makes remote improvement possible also makes remote subtraction possible. The solution is not to freeze appliances in time. Connected products do need security updates. An unpatched refrigerator with cameras, microphones, credentials, or network access can become a liability long before the compressor dies. Consumer Reports found in 2024 that among 21 major appliance brands it examined, only 3 clearly disclosed how long they guaranteed software and application updates. That transparency problem matters because buyers cannot rationally compare 2 refrigerators if they know the energy rating, but not the supported lifetime of the software. Consumer Reports. Innovation. The general rule sets at least 5 years unless the product is reasonably expected to be used for a shorter period, and longer expected lifetimes can justify longer support. The regulation also requires clearer information about the end of support and is designed to make security maintenance part of the product lifecycle rather than an optional favor. EUR Lex. Most of its core product obligations apply later, but parts of the regime are already phasing in during 2026. This is significant because it changes the question from will the company support this to what support period did the company commit to? But cybersecurity support does not automatically guarantee every cloud feature forever. EUR Lex. A manufacturer could patch vulnerabilities while still retiring a recipe service, remote camera feature, or subscription platform. Security regulation and functional longevity overlap, but they are not the same problem. Right to repair rules face a similar boundary. Repair law is traditionally built around broken hardware. Access to parts, tools, diagnostics, manuals, and fair repair conditions. A cloud-dependent feature can disappear even when nothing is physically broken. What does repair mean when the missing component is a server the manufacturer chose to shut down? A technician cannot solder the cloud back into existence. This is why future repair policy will increasingly have to address software continuity, interoperability, pairing, and end-of-life transition plans. One possible answer already exists in open-source thinking. If a manufacturer no longer wants to operate a service, allow others to maintain the software. The Cyber Resilience Act itself encourages consideration of source code release after support ends so vulnerability handling can continue. But that approach collides with proprietary algorithms, licensing agreements, security concerns, cloud architecture, and third-party intellectual property. EUR Lex. A smart appliance may contain code from dozens of suppliers. Opening one layer does not recreate the entire service. The stronger long-term design is simpler. Essential functions should not require the cloud in the first place. Temperature control should remain local. Manual cycles should remain local. Safety systems should remain local. Basic diagnostics should be readable locally. Cloud services can enhance the appliance without becoming the appliance. This idea is sometimes called graceful degradation. When the network disappears, a gracefully degrading product loses remote convenience but remains complete enough to perform its essential job. When the manufacturer disappears, it does not become e-waste simply because an authentication server vanished. Graceful degradation sounds obvious, but it conflicts with some business incentives. A product that can function indefinitely without the vendor has less leverage for recurring revenue. A product that depends on an account can maintain a customer relationship for years. That relationship can generate subscription fees, accessory sales, service appointments, data, advertising opportunities, and upgrade prompts. None of those outcomes require deliberate sabotage. They require dependence. And dependence is profitable because it converts a finished transaction into an ongoing channel. This is why the most important question when buying a smart appliance is no longer, does it have Wi-Fi? It is, what stops working if the manufacturer disappears tomorrow? If the answer is only remote notifications, the risk may be acceptable. If the answer includes temperature configuration, core cycles, authentication, repair pairing, or essential diagnostics, the buyer is assuming a very different kind of risk. A second question follows, how long are software and security updates guaranteed? Not promised in vague marketing language, guaranteed. A third question is whether downloaded capabilities remain stored locally after support ends. A fourth is whether replacement parts can be paired and configured without a vendor-controlled service. A fifth is whether the appliance exposes documented local controls or an interoperable interface. Those questions sound technical because ownership itself has become technical. In the mechanical era, possession was obvious. If the machine was in your house and you could repair it, you controlled it. In the connected era, control can be distributed among the owner, manufacturer, app store, cloud provider, identity provider, and software supplier. You can hold the entire appliance and still possess only one piece of the system that makes it useful. That is the deeper meaning of the 2026 smart appliance problem. The industry does not need to place a countdown timer inside every refrigerator to create premature obsolescence. It only needs to build appliances whose useful lives are bounded by infrastructure customers cannot own, inspect, replace, or keep running. Sometimes that infrastructure will survive for the lifetime of the product. Sometimes a subscription will fund it. Sometimes regulation will force longer support. And sometimes, as June oven owners learned in 2026, the physical machine will remain on the counter after the digital product around it has been scheduled for deletion. The most defensible conclusion is not that every manufacturer is intentionally bricking appliances to extort a monthly fee. There is no evidence for a universal coordinated scheme, and many connected features are optional, useful, and supported responsibly. The stronger conclusion is that manufacturers are intentionally building software-defined appliances in which they retain extraordinary post-sale control. That control creates the ability to monetize features later, to require subscriptions for some services, to change interfaces, and to terminate cloud functions. Whether that power is used aggressively depends on the company, product, economics, and regulation. But the power exists because the architecture was designed to preserve it. And once consumers understand that, the language of smart begins to sound incomplete. A smart refrigerator is not just a refrigerator with more capability, it is a refrigerator with more dependencies. A smart oven is not just an oven with software. It is an oven whose future may partially depend on a corporate roadmap. A connected washer is not merely a machine that talks to your phone. It is a machine participating in a digital service whose rules can outlive the sales receipt and change before the motor wears out. That is why the September 22nd shutdown of June's cloud matters. On that day, the ovens are expected to keep heating. Their owners will still possess the same metal, glass, sensors, camera, processors, and heating elements. But some of what made those objects June ovens will no longer exist inside the home, because it never fully existed there in the first place. It existed in an arrangement between hardware and remote infrastructure. Consumer Rights Wiki. And arrangements can be terminated. The future of ownership will therefore depend less on whether a product is connected than on whether connection is optional, replaceable, and reversible. The best smart appliances will be the ones that can survive their manufacturer's servers. They will keep essential controls local, publish support periods, separate security updates from feature monetization, and degrade gracefully when cloud services disappear. They will allow repair without requiring perpetual permission from a distant account system. They may still sell subscriptions, but the subscription will add a service instead of holding purchased hardware hostage. That is the line between a product that becomes smarter through software and a product that becomes dependent on it. The smart appliance revolution was sold as a way for machines to improve after we bought them. In 2026, the more important discovery is that the same architecture can make them smaller after we buy them too. The appliance can remain in your kitchen, perfectly capable of doing what its processors and sensors were built to do, while the right to use part of that capability vanishes remotely. That is not traditional failure. It is not ordinary wear. And it is not always a literal brick. It is software-defined ownership reaching its logical conclusion. When the machine is yours but the permission is not, ownership is only as permanent as the service behind it.